The classic scenario we've all encountered. Your daughter is busy crushing a plate of mac and cheese with her bare hands. You muster your parental superpowers to scoop her up for a quick hand washing, but suddenly, your old and out-of-shape back goes up against your ever-growing toddler. Let's be real. We're not the surprise spring chickens we once were, and you might have had a few too many of those bowls of macaroni and cheese yourself. But fret not, my fellow fat friends. We are the engineers of our own destinies. We can craft a solution out of this predicament without hitting the gym or eating salads. Well, the wait is over. Introducing the Toddler Elevator 2000, the marvel of overcomplicated and meticulously executed parenting innovation. And guess what? You can have your very own for the low, low price of neglecting your spouse and child over countless evenings and weekends. But wait, there's more. Keep watching this video and I'll reveal the intricate design and engineering wizardry that brought this one-of-a-kind toddler elevator solution to life. As I delved into designing the toddler elevator, I brainstormed various concepts in CAD. In the end, I settled on a gear-driven mechanism, mainly because I just thought it would look cool. Let me know if you would have done something different. The design I landed on features two sturdy side pieces connected by four lap-jointed cross members. Inside that, there's going to be this elevator housing or box thing, and that's where I'm going to stash the motors, electronics, and gears. Each side will have its own motor powering a single gear, and then that is going to drive the other gears to then drive the elevator up and down the racks that are carved into the side pieces. I think it's a simple yet effective solution. I plan to have the elevator controlled wirelessly, and those up and down buttons are going to be housed in this upper cross member. Once I had the design concept nailed down, it was just time to roll my sleeves and get to work. So I decided I'm going to be using cherry for this project to match my cherry kitchen cabinets. I start out at my miter saw by cutting lumber into more manageable lengths before heading on over to my joiner. There, I flatten one face and square an edge. Now, a couple years ago, I actually installed a helical cutter head into this old grizzly joiner, and I have to say, it is well worth the investment. Alright, next, I head on over to the planer, where there I'm going to even out the thickness across all the boards, and then using a cut sheet I made from my CAD model that you saw previously, I cut the boards close to their final widths. Now, I'm leaving everything out overnight to let it acclimate and then check if there's going to be any movement that might require some additional milling. Now at this stage, everything remains oversized and I'm going to be coming back and really, final cutting everything to size. Now that we've successfully navigated the thrilling world of milling, let's move on to cutting and assembling the two large side assemblies, which are made of two small horizontal and two long vertical pieces. The horizontal and vertical pieces will be connected at a miter joint, and the sharp corners will be cut off at a 2-inch radii. I chose a miter as I thought it would just be the most aesthetically pleasing with those corners cut at a radius. Using my miter gauge set to 45 degrees, I cut one end of each piece off, and then I flip everything over and I mark out where the other miter cuts are going to go. These cuts are going to determine the final length and width of the side assemblies, and to make sure that everything comes together and is uniform between the two side pieces, I'm going to be using stop blocks to get nice repeated cuts. Next, let's talk about the secret ingredient for a toddler-friendly touch. You see, my initial vision didn't involve anything obscuring these gears, but my dear wife had some safety concerns, and I have to say, she's probably not wrong. These gears are begging to crush little fingers. So I'm going to be cutting in some grooves where I'll put in a sheet of plexiglass that's always going to cover those gears and make this whole toddler elevator a lot more OSHA and toddler compliant. It's essential to note that the grooves don't extend the entire length of the piece. I mark the height I need the grooves to go and the direction of the cut. For the grooves on a single side assembly though, to form one large groove for that plexiglass to ride up and down in, they can't both be cut in the same way since they're mirrored to each other. It'll make a little bit more sense when you see it, but just trust me. So in order to do this, I need to make a series of stop and drop cuts. Once the vertical members are marked, I then need to mark on the fence where the center of the blade is. I use this line to determine where my stop cuts end and where my drop cuts begin. The stop cut is straightforward. You run the board through as usual, and then abruptly stop when the line of your workpiece meets the line on your fence. A drop cut, however, requires a little bit more finesse. You lower the piece slowly under the spinning blade, starting with your marks lined up, and then running the piece through the remaining length. This procedure demands the utmost caution and involves the riving knife being removed, so safety first, unless you're blessed with a saw stop. But for real, this thing could kick back on you, so be careful. To attach these pieces, I'm going to be using dominoes and my homemade domino joiner because, well, it's budget friendly and I don't have enough money for the real thing. And Festool, if you're listening, I could certainly use a free upgrade. Let's be honest, this channel's main goal is to get free tools. Just kidding, but not really. Now, each of these pieces that make up the side assembly is a lot wider than they need to be. They're about 3 inches when I want them to end up at about 2 inches. I'm doing that because I'm going to be using my CNC machine to cut out that inner profile with the gear rack in it. Now, these mirrored vertical pieces won't have the gear rack in the same exact position, and that's just because all the gears need to line up. So cutting it out after it's fully assembled is going to be way more precise. Now we are ready for glue up. When gluing up miters or any strange angle, it's nice to either use cutoffs or some piece of scrap that you've cut at the same angle. With those, you can super glue them directly to your workpiece right at the joint and clamp everything nice and tight. Basically what this allows you to do is put all that clamping pressure perpendicular to the joint, creating a much better and easier clamp up. Once everything looked good during a quick dry fit, I smear on some glue everything up, and then all I have to do is repeat for the other side assembly and let everything dry overnight. While that dries, let's dive into making the gears themselves. To enhance the overall aesthetic and contrast with the cherry wood, I've opted to go with maple for the gears. To make these gears as strong as possible, I'm actually going to be making each gear out of 2 pieces of 1/4 inch thick maple glued together with the grains perpendicular to each other. By using this method, we prevent the occurrence of a gear tooth's root having the wood grain running across it, which might weaken the gear and potentially lead to breakage. In theory, this seems like a good idea, however, it could all just be overkill and a giant waste of time. I don't know. Once the gears are glued together, I can then put them on my CNC machine and basically just press start. Now this truly is the biggest benefit of owning a CNC machine, because if I had to use a template to cut out 8 gears, it would just take way too long and be way too tedious for me. Alright, now off camera, I cut the 4 cross rails to their final dimensions, so that while I was at the CNC machine, I could just take that opportunity to carve out the space in one of the cross rails where I'm going to house the wireless motor controls. I designed this compartment with a magnetic door to keep all the electronic components neatly hidden, yet easily accessible. On the front of this cross rail, I added in some machined arrows, which I'm going to fill in with black epoxy, and then that's going to be right next to the corresponding button for the controls. The small holes you see here are precisely where the up and down control buttons will be installed, ensuring that all the controls are both discrete and user-friendly. Now that my side pieces are glued and dried, it's time to dive into cutting the lap joints for the cross rails, and this is going to be bringing everything together. Normally you might think, why not cut these joints before you glue up everything? Well, I thought about that, but I kind of figured waiting till after would just make everything come together a little bit easier. For these lap joints, I'm calling in my trusty crosscut sled, a spacer block matching the exact width of my blade's kerf, and a cross rail piece itself. If you follow these steps, you should get a very simple and easy tight-fitting lap joint. So first, I'm going to position the spacer block between my stop block and the workpiece itself. Then, make your initial cut. Now remove that spacer block and put in the cross rail piece, or whatever you're using to put in the lap joint, and position that between your workpiece. Then make your second cut. Now, make multiple cuts in between the first and second cut to clear out all that excess material. Now this method should ensure that that lap joint ends up the exact width of the cross rail. Now without that spacer block, you're actually going to get a width plus the kerf of your blade. And that's it. Pretty simple. All I have to do is repeat that 7 more times and I should have 2 side rails that come together quite nicely. The next step is routing the inner profile and gear rack into the 2 side pieces. As I mentioned earlier, I intentionally left these pieces wider than necessary to ensure that I could cut the entire inner profile uniformly and in one go. And this will just kind of create a nice, clean and consistent look. So I head back on over to my CNC machine for this cut, but I don't cut all the way through because that would just take all day. Instead, I'm going to make a cut of about 1/4 of an inch deep and then remove all the excess with a jigsaw. Now I'm going to cut that excess, staying as close as possible to the workpiece. That way there's just a little bit that I need to come back and remove, and I'll do that with my router and a flush trim bit. And that's going to make everything nice and perfectly even and smooth. However, here's where I made a bit of a goof. You may remember from my CAD model that the gear rack teeth don't get cut all the way through the side piece. There's a little bit of material on the outside that covers those gear teeth. Well, in a moment of rushing and not really thinking things through, I decided to trim the excess waste around those teeth before I realized, oops, I'm cutting through the entire thing right now.
It was at this moment that he knew. He f***ed up.
Mistakes this late in the game are incredibly frustrating, and I'm kicking myself for not taking it slower. But that's where creativity and woodworking skill come into play. Or, in my case, leaning on a technology crutch that is my CNC machine. I opted to cut out a block of material right at the section where I messed up, down to about the level where the gear teeth should be. Then I'm going to just cut a patch, try my best to match the color and the grain as close as possible, and I glue that patch right on in. Now, it might not be perfect, but all in all, I think it turned out pretty darn good. Sometimes it's those unexpected twists that make a project truly unique. After the patch dries, I can flush trim and sand it until you won't even really be able to know it's there. Well, unless you watch this video, that is. Finally, at long last, I can proceed to the glue up stage where the side pieces and cross rails are joined together, giving birth to the skeleton to our trusty elevator. Wrangling all these pieces into position was a bit of a pickle, and there was some gentle malleting involved to coax everything into place. Threw everything into clamps, and just let it glue up overnight. To give this toddler elevator a more polished look and a baby smooth feel, pun intended, I used a round over bit on my palm router to soften those sharp edges. After that, it was a gradual journey through different grits of sandpaper, making sure everything is as smooth as it can be. Now you might have to squint a bit, but you can see that patch we talked about earlier. I think after the sanding process, it's actually, pretty impressive that it came out this inconspicuous and really blends in with the rest of the surrounding wood quite nicely. With the frame complete, we're almost ready to transform this into a fully operational elevator. But before we get to the exciting part of assembly and electronics, we need to take care of two crucial components. First, the box that will house our electronics, and then the platform for the elevator itself. Now, I'm not going to bore you with every little intricate detail here, but for the platform, I kept it real simple. I did a straightforward panel glue up, and then I cut out 4 corners to create a nice snug fit in and around the side pieces. One little safety touch I did add was some corner bumpers to make sure no curious little toes find their way into any moving gears. After all, safety comes first. As for the box itself, it's precisely what it sounds like. It's a box. I assembled it using tried and true rabbet joints, and then put in some dowels for a little added strength. No need for fancy frills or creative joinery here. We're going for pure simplicity and functionality. Now that everything's neatly glued together, it's time for the finishing touch, which is, well, finish. Doing this before assembly is going to be a whole lot easier. For this job, I'm reaching for a Rubio monocoat, and there's a good reason why. First, this is on YouTube, so obviously. And then second, I just genuinely love how straightforward this finish is to apply. I'm going with Pure for the gear assemblies, which you can see are now also glued up, and I used some cherry wood dowels for the gear shafts. As for all the other pieces of this, I'm actually going to be using the cherry Rubio monocoat on cherry wood. I know it kind of sounds a little unusual, but it was the thing that achieved the best finish to match my kitchen cabinets. Applying this finish is super easy. You simply rub it on and then wipe away the excess. It's that simplicity and ease that make Rubio monocoat my favorite, and it's a perfect choice for a smooth, hassle-free finish that'll make this elevator project truly shine. Once the finish is dried, we're ready to bring everything together, and the first step involves assembling all the gears to the box. Now, I'm using these rotary bearings, and they snugly fit onto the cherry gear axles, which are then going to dock into the holes in the side of the box, thus aligning all the gears. At this point, I'm pretty cautiously optimistic because even though gears aren't rocket science, I'm really kind of left wondering if all the tolerances are correct and this thing's even going to come together at all. But once everything is in place, it aligns beautifully and functions just as it should. I decided to run a quick test with the frame to see if the gears move up and down smoothly, and lo and behold, it actually seems to work. Well, at least for now. Then I attached the platform to the box using some Z-clip brackets. Now these are going to ride into some grooves that I cut into the box earlier. This is going to securely attach the platform to the box and allow for some seasonal wood movement. It's time to talk about how I'm going to raise and lower this elevator with some motors and electronics. So I need something to attach to these gears to raise and lower everything, and I'm going to be using these two worm drive motors. Now these motors are fantastic for high torque applications. You do make some sacrifices with speed, but that's fine. I don't need a lot of speed out of this little elevator. Basically the way these work is very similar to any other motor, except it's turning a little worm gear, and then that worm gear is going to turn a series of gears to provide torque to the output shafts. Now, another reason I'm using these worm drive motors is because they're basically self-locking. Basically meaning that worm gear can drive all of the gears, but those gears can't then come back and drive that worm gear. So the reason that's great is once I get this platform up to where I want it, I can don't have to keep providing power to the motor, and it should keep everything right in at that location. So that's a really obviously important feature for this. I don't want my kid to come crashing down. I'm going to be connecting these to the cherry dowels, aka kind of like the axles for these gears. Basically, I'm just going to drill a hole right in the center, cut some little slots, and then I'm going to basically press those on, and then I'm going to have a little pipe clamp to just squeeze down. That I think should provide enough kind of friction to drive everything. If not, I'm going to have to potentially try and get a little bit more creative. Those motors are going to be controlled wirelessly by this remote, and I'll talk about that in a second. But it's going to come to this little motor controller. Now this is right off the website, and I'll link everything in the description below. But basically this is intended to be for if you have, say, a projector screen or something like that you want to raise and lower in a conference room. This is one of the things that you would potentially use. So it has a little RF sensor that can detect the signal coming from the remote. You plug in power. On this side, it's got a couple ports for some limit switches, which I'll talk about, and then it has where you'll hook up the motors to. So basically I'll send a signal for up or down. That's going to signal to drive the motors one direction or the other. These limit switches, I bought some magnetic limit switches. Basically what this is going to say is once I get to either the higher or the lower limit, it's going to cut off those motors when it gets to when these magnetic limit switches line up. So I'll have to install those. And that's just going to prevent this thing from crashing, going too far up when it runs out of the rack for the rack and pinion on this mechanism. The remote. So I intend this to be built into that top rack. That's where I milled out that pocket and had those little epoxy up and down arrows. I want to use these little panel buttons. Those are going to be a little bit easier to press rather than just kind of having this little dinky remote. So on the inside here is a little circuit board. It has a tiny little soldered buttons. That's what these buttons are pressing on. I'm going to attempt to remove those and then somehow solder these little panel buttons on. And then hopefully all of that will fit into that top rail. And then I'll be able to wirelessly control the motors from there. And then everything is going to be powered with this 10,000 milliamp battery. It's meant for like an e-bike or something like that. Should have plenty of juice for what I need it for. So I'm going to go ahead and start getting a lot of this stuff wired up. And then as I start assembling, get all these electronics into that box housing that we made that all of the gears are going to go into as well. So let's do it. All right, going to demonstrate some of these electronics. So once again, here's the controller. Hook it up to the battery here. See, you got the little LED come on that has power. Here's the RF sensor. Here is the magnetic limit switch. There's one more that you can put on, I just don't have it on yet. So currently here's the remote. It's set up in momentary mode. So that means as you're holding down the up arrow, it'll go up. As you hold down the down button, it'll go down. And then you can see that the way that the limit switch works is even if you're holding the button down, it'll cut it off, but it'll still go the opposite way. After confirming that the controller and limit switches are functioning properly, I move on to the task of rewiring the remote control to integrate it with the panel buttons. To access the 2 push buttons on the remote, I dismantle it to expose the circuit board. These buttons are soldered on, so the next step is to desolder them. Using my soldering iron, I apply some heat to the connections on either side of the push button, allowing them to come off quite easily. With the original buttons removed, I can now carefully solder the wires of the panel buttons onto the same connections on the circuit board. After a quick test to ensure everything is functioning as planned, I install the modified remote controller into the upper cross member of the elevator. This setup ensures that controlling the elevator is incredibly convenient, and to keep everything nice and discreet, I can conceal it with that magnetic cover plate. After installing the rewired remote control, I proceed to mount the motors and electronics into the box. I first start by aligning the motors with the drive gears on each side and then connect all the necessary wires between the battery, motor controller, and motors. Now during the initial test, however, I noticed there was quite a bit of slippage between the motor and gear axle connection, causing everything to kind of get out of misalignment. I guess here I was just really foolishly optimistic, thinking that clamping friction fit was going to be strong enough. So I kind of rethink some things. What I decided to do was I'm just going to drill and then cross pin through the gear and motor axle, and that's should provide a much more rigid connection. A little hack here is I'm actually going to be using the drill shanks themselves as the cross pin, as this is just a really cheap way of getting not only a strong cross pin, but it's also going to perfectly fit the hole that I just drilled. This modification seems to have created a much stronger connection that firmly links those two, and when I retest it, everything seems to be working much smoother and better now, even with putting a lot of downward force on it. So next I install some magnetic limit switches at the bottom and top positions where I want the platform to automatically come to a stop, and then I finish everything off by installing some plexi safety glass panels over the gears. I secure them in place using CA glue and adhere them to the platform. The elevator is now equipped with additional safety features and is ready for operation. After all that, we're finally done. I really enjoyed this project, and for the few of you who made it to the end, I hope you really enjoyed watching this, and I hope to see you all on the next video. Thanks.